You can create Excel-like pivot tables in R using multiple tools, and one of the tools is tidyquant. So let's explore this today. So I'm using the tidyquant library, and I'm also using flex table library and dplyr library, lubridate library, and finally the scales library. So let's see what it does for us. So let's create some data, and the best thing would be to use some shares data from tidyquant, and simply by saying tq-get and describing the symbol of the share, you can actually get the data. So I've got the data, and it has number of fields like open, high, low, close, and adjusted value. So we can use one of them to start creating our tables. So let's modify this data. So first of all, I want to create the year using the lubridate package. I'm converting the date field into year. Next, we would need the months. So I want to have the month name, like full month name, as January, February, March, etc. So again, I'm using the lubridate package. Using lubridate, I'm saying month, and I want the labels to be placed. Instead of number 1, 2, 3, 4, I want to see it as January, February, and I don't want to see it as abbreviated like Jan, Feb. I just want the full names, and I just want to use the year, month, and the adjusted price of the share. So if I look at the final data set, you would only see the year, the month as January, February, etc. That's what we wanted, and the adjusted price of the share for each day. And now we can start creating our table. So here's the structure of the code. The first thing would be to refer the data set which we created, df, as you can see on the right hand side. So using this, we are passing it through the pipe to the tidyquant pivot table from tidyquant library, the pivot table function. I'm going to say in a pivot table you have rows and the columns, and then the value which you want to show in those cells. So starting with the rows are going to be dot rows equal tilde sign and the month field. So there is a peculiar way of defining it. So the rows and columns start with dot rows and dot columns, and your actual data field starts with the tilde sign. So follow that syntax when you write it. So columns, again dot columns equals tilde year. And finally, we need to define what are the values going to be. So dot values equals again tilde. And what is the value going to be? We want to use maybe the mean price or the mean adjusted price. So using the command mean, passing the value of the adjusted price, so adjusted, and that should do the trick. So we have something which is kind of working. You can see that at the bottom, but let's pass it to another table. So I just want to pass it to another data frame called tbl1, and I want to display it using flex table so that we can see it in a proper fashion on the right hand side. Here we go. We have the month and the years, and then the actual adjusted price for each of those months. So the mean of the adjusted price is being shown. But you can see that there are a number of decimals after that. How can we control those? Remember that when we defined our libraries, we also called the scales package or scales library. So let's use that. So I'm saying scales, and there is a command in that which is called number, and we can actually define the accuracy. So by saying accuracy equals 0.1, and if I do that and let's run it, so what if we wanted to increase the number of decimals? So if I put .2, 0.2, so accuracy equals 0.2, is it going to change anything? No, it doesn't change anything, because now the accuracy is 0.2 instead of 0.1. The accuracy has changed to 0.2, but it doesn't mean there are 2 decimals after that. But now if I say 0.01, then you would see your data is accurate to the 0.01 of the price. So that makes it like 2 digits. So that's how you can control it. If you wanted 3 digits, you will say accuracy equals 0.001. So that's how you control the accuracy of your data. So we saw how we can create a pivot table and then store it in a data frame. But now let's see how we can actually create a nice looking presentable or a publication ready table out of that so that we can use it in our Word documents or other things. So we can enhance the basic flex table which we were using before. So let's use the theme zebra, which comes with the flex table. And if I do that, you would see that we have alternating lines highlighted gray, but we can obviously go and change them. So I'm saying odd header equals gold. So the top header has suddenly turned to gold color or golden color. And let's see if we can change the individual highlights of the alternate rows. So we can say odd body equals light blue, and you can see now the color has changed. And finally, we can piggyback with another theme. So I'm using the theme box. So it's actually piggybacking it. So I can use some functions from theme zebra as well as theme box. Now let's see some other special features which you can use in the pivot table command. And one thing which sets it apart is that it has the ability to do a lot of financial calculations on the fly, and you can also make your own functions if you want. So for example, in this case, I'm just doing the median calculation, just saying median of the adjusted price, and here we have the median data. You can also use capital. I realize that it takes both. So even if I give capital median, it takes it. Now I tried the same thing with the count. So if I said, give me the count of the adjusted prices, how many times adjusted prices was there, it gave me an error. But the moment I converted this into capital, it works. And now let's say, what is the maximum price? So we got that value. So I'm going to use that and do a countif as similar to what we do in Excel also, countifs. So I'm saying countif, the adjusted price, or X equals maximum of the adjusted price, which we just saw it up there. And using this, I got one value. So in 2023, in September, the price was maximum. So this is quite a good feature. And similarly, you can obviously make some more changes. For example, in this case, I'm saying as long as the price is above the 75th quantile, give me the output of that. So it just gives you the number of days the price actually reached the P75 or 75 percentile. You can also check what was the price on the first day of the month and the last day of the month. We can also do standard deviation by using st command, and we can also calculate the returns. For example, we can say percentage change from the first of the last of the month, and then it gives you the return for that month. So you can see 3% or minus 5%. This is the change from the first day of the month to the last day of the month. I hope you found this information useful and practical. Thank you very much for watching it, and I'll see you in the next one.